Okay, Assalamualaikum class. Let's continue on the third video of the chapter 11. So the video that you learned before is about the instantaneous power. That is PT is equal VT multiplied by IT, right? And from this instantaneous power, you're going to get what we call average power. That is P is equal half VMIM cosine theta V minus theta I. Okay, so from the one that we have learned before, instantaneous and average power, so now we move to another term that is what we call complex power. So when talking about complex power, you're going to deal with what we call phasor. So you have V in the phasor is Vm angle delta V, current is equal Im angle theta I. And then how to calculate the complex power from the phasor. Okay, so what is complex power? So complex power denoted by S, the bold S, because this is a complex number, is the product of the voltage and the complex conjugate of the current. So what is complex power is equal to half the complex voltage. So this is the bold V, this is the bold S, multiply by the complex conjugate. So what do you mean by conjugate? Conjugate, so if you are given I is equal 5 angle 40, so what is the I conjugate? 5 angle minus 40. So you need to conjugate it. So this is important, right? And you need to divide by half. Divide by half. Half the complex voltage and also the complex conjugate of the current. So this is the first formula that you need to remember for the complex power. Now we want to see the relation between this complex voltage and complex conjugate of the current if the question given in RMS. So remember in the previous video, what is RMS? So V RMS is the effective value. So how you relate with the normal or complex voltage is Vm over square root 2. So, and you can also denote your complex power, the bold S, is equal to the complex RMS of the voltage multiplied by the complex conjugate of the RMS current and conjugate it. Okay? So the one that you need to remember is only this yellow highlight here. Okay. So remember last time you learned about the formula of power in chapter 1 and chapter 2. This can be either I squared R or V squared over R, right? So now you just need to change it to become I RMS. You modulus it, means you need to find the magnitude, and also the V RMS, you modulus it, and then you do the Z here is divided by the Z conjugate. Okay, so but we suddenly use this formula. So the one that we are going to always use is you need to hold to this formula. Half VI conjugate equal V RMS I RMS conjugate. Now we want to see the relation, how to find from this complex conjugate goes to the RMS. So as we know, the V RMS is equal to V over square root 2. This is complex. Okay, and I, the bold I RMS is equal I over square root 2. So you need to substitute this in the equation. So we can half. So what is V? V is V RMS square root 2. What is I? I is equal I RMS square root 2. So now substitute number 1 and number 2 inside this equation. So you know half VI conjugate. So what is V? V from equation number 1 multiplied by V RMS square root 2 multiplied by I RMS square root 2. Now square root 2 multiplied by square root 2 means you're going to cancel the square root. So it becomes 2. Then 2 divided by 2 will be 1, right? So finally you can get this one inside the conjugate. So V RMS I RMS conjugate. This is the equation for the complex number. So you have two equations here. The first one is S equal half VI conjugate, or you can use VRMS IRMS conjugate. So in order for you to solve the complex power, just hold to these two equations, equation 1 and equation 2. Okay, so let's see what is the formula. Okay, so this is from the equation 1 previously. So you know that S equal to half VI conjugate, right? And then you just and also what is half VI? This one is VRMS IRMS. This is the complex power, and then the conjugate. Okay, from the VRMS IRMS conjugate. So you need to change this phasor to the polar form. So number one, you know that VRMS is equal, this is the bold V, okay, is equal to VRMS angle delta V. Number two, I, the bold I, RMS is equal I, the amplitude and the angle of the current. So if you say here multiply, so you just take out VRMS IRMS. Now it is added, right? So delta, but you need to have the conjugate. So let's change this one to conjugate. So it become I RMS minus delta I. So you have equation number 1, equation number 2. So when you multiply it together, the magnitude you're going to multiply, but the angle you're going to add. So it become delta V plus minus, where this minus comes from? Due to the conjugate. Minus delta I. So this is what you are going to get after you multiply it together. S equal VRMS IRMS delta V over delta I. Now let's change this one to the polar form. So what is the polar form saying? So how you change R equal delta theta to the polar form is equal to R cos theta plus J sin theta. So if I want to change this S to a polar form, so your S is equal to VRMS is the R, right? IRMS. So you start with cosine first. Cosine theta V minus theta I. Now you move to the imaginary. There is J. What is the constant? VRMS IRMS sine theta V minus theta I. So you can get the same with what is showing here. Okay. So from here we know that your P here is the whole real number here. This is a constant. VRMS IRMS cosine theta V minus theta I. But your J, this is J, right? But your Q here is VRMS IRMS sine theta V minus theta I. So this P here we call average power in the real power. So it's the same that what you learned before. Okay. The blue one here is what we call reactive power. So this one comes from the either inductor or the capacitor, because it have what we call capacitive inductive loads. If your Q here is equal to 0, there is purely resistive load, there is no L and C. But if your Q is more than 0, it is inductive. If your Q less than 0, it is capacitive. Okay, so inductive here means slack, capacitor here means lead. How you remember this one? Ellie the Iceman, right? If this capacitor, I will lead voltage. If this inductor, I will lag the voltage. So we call lagging. Okay. So if we see the notation here, so the whole here is the real power or average power and here is what we call reactive power. This is a real power. Okay, and how you calculate the apparent power? So the apparent power, if we change back this one to polar form, so it become S equal V RMS. If we change back this polar form, V RMS I RMS theta V minus theta I. So what is the apparent power? So this is the magnitude is the apparent power. The first one here. Okay, this is the magnitude of the polar form. Okay, so if I write in the polar form here, V RMS I RMS angle theta V minus theta I. So what is the apparent power? Is the in front one here. This is what we call apparent power. Reactive power is the Q. Power factor. So what is power factor? Is you just add this cosine, whatever we have inside the complex power, delta V minus delta I. So this is how you calculate. So apparent power, what is the unit? Is VA. Real power is watt. Reactive power is VAR. And for the power factor, you don't have any units. Okay. So if you see this explanation, so when you have a positive Q more than 0, we call this one lag. When you have a negative Q or less than 0, we call this one lead. So lead means capacitive, lag means inductive. Or you look at the angle perspective. If delta V minus delta I more than 0, it is lag. If delta V minus delta I less than 0, it is lead. Okay, so from here you are going to know your circuit is leading or lagging. Okay, so we'll see the example in the next video.